SpaceX is about to light a fire that could change everything. A brand new rocket sitting on a brand new pad, running brand new engines that have never been tested before, all at the same time. That almost never happens in rocket science. Engineers usually change one thing at a time. SpaceX is changing everything at once, and the reason they're doing it now under a tight deadline, with NASA watching and a competitor closing in, is what makes this moment so much bigger than just a test fire. The rocket is called Block 3 Starship. It is the most advanced version of the most powerful launch system ever built. The booster alone is supposed to run 33 engines simultaneously. That has never been done with this new engine design. Before any of that can happen, SpaceX has to prove the basics work. They have to load the tanks, spin up the pumps, light the engines, and make sure nothing breaks. To understand what is actually at stake here, you need to know three things. First, what SpaceX is, testing right now, and why they are being so careful about it. Second, the history behind why they always start small, and what happened when one early Block 3 booster was lost in an accident. Third, what this whole test campaign is actually building toward, and why losing a race to Blue Origin could cost SpaceX the most important mission NASA has ever handed a private company. The booster sitting at the pad right now is called Booster 19. It is the very first Block 3 Super Heavy ever built. It rolled out to Pad 2 around March 8th. Pad 2 is also brand new. It was built from scratch over many months and has a completely redesigned launch mount and a proper flame trench underneath it. So SpaceX is testing a new booster on a new pad with new engines. That is a lot of unknowns to manage at once. The first unusual thing you would notice about Booster 19 is that it only has 10 engines installed. A full Super Heavy needs 33. So why does this one look so empty? It is not a mistake. It is the plan. SpaceX does not push a new vehicle to full power on day one. They start small, check everything, then add more. It has been their strategy since the beginning of the Starship program, and it has never changed. Before Booster 19 even arrived at the pad, it had already been through at least 4 cryogenic proof tests at the production site. Cryo tests work by filling the tanks with extremely cold liquid oxygen and liquid methane, then pressurizing the structure to make sure it holds. These tests find cracks, leaks, and weak points before the engines ever light. By the time the booster rolled to Pad 2, engineers already had confidence in the tank walls. That is important because Block 3 uses bigger tanks than any previous version. Once at the pad, the pace picked up fast. On March 10th and 11th, SpaceX ran its first tanking operations at the new facility. They practiced loading propellant, then unloading it. They tested pressurization. They checked that the new ground hardware was keeping up with the new vehicle hardware. One detail caught a lot of attention. The liquid oxygen tank filled faster than expected. That is a good sign for both the upgraded ground systems and the larger tank design. Then came the night of March 12th. Another tanking test happened, and observers noticed signs of what is called a spin prime. A spin prime is when the turbo pumps inside the engine spin up to operating speed without actually igniting. Think of it like revving a car engine without putting it in gear. It is the last rehearsal before the real thing. Frost covered the methane tank. The booster was loaded again, then detanked once more when the session ended. All of that leads to the next step, which is the static fire itself. A static fire is a ground test where the rocket stays bolted to the pad while the engines light for a few seconds. The vehicle doesn't move, the clamps hold it down. But all the real mechanical stress happens. The engines ignite, propellant flows, pressure builds, the structure flexes. Engineers get data on whether everything actually works together at once. not just in separate tests. If something is wrong, a static fire finds it before a flight does. For Booster 19, the first static fire will likely use just the 10 installed Raptor 3 engines. That is a deliberate choice. SpaceX does not want to risk a brand new booster and a brand new pad with a full 33 engine firing right out of the gate. So they go small first. If that works, Booster 19 will return to the production facility to have the remaining 23 engines installed. Then comes the big test. All 33 Raptors lighting at once. That is the one that will truly show what Block 3 can do. This pattern is not new. Look at the history. Back in 2021, Booster 3 was the very first Super Heavy to ever do a static fire. It lit only 3 engines. The point was not power, the point was proof. Then came Booster 7, the one that flew on the first integrated Starship launch attempts in 2023. SpaceX started it with a small engine static fire, moved up to 14, then eventually reached 31 of 33. One engine was deliberately shut off. Another tripped out on its own, but the approach held. Start low, scale up. The same pattern repeated with boosters 8, 9, and 10, each starting at 7 engines, then moving to 14, then higher. The Starship upper stages follow the same logic. Most ships begin with a 3-engine static fire using only the sea-level Raptors, then validate the full 6-engine setup later. SpaceX treats every new vehicle like a new experiment, not like a repeat of the last one. Now there is something important about why Block 3 took longer to get here than expected. The very first Block 3 booster was not Booster 19. It was a different vehicle, and it was lost. In November of last year, that booster was destroyed in an accident on a test stand. No one was hurt, but the vehicle was gone. That setback pushed the entire Block 3 timeline back by several months while SpaceX built a replacement. Booster 19 is that replacement. At the same time Booster 19 is going through pad testing, the Block 3 upper stage is also being prepared. It is called Ship 39. Ship 39 rolled out to the Massey Outpost test site in late February and went through its own round of cryo-proof tests. It completed at least 3 full sessions, loading liquid oxygen and methane each time to check the tank structures and propellant systems. Engineers also ran what are called squeeze tests, where simulated chopstick arms press against the sides of the ship to replicate the forces it will feel when the Mechazilla tower grabs it after landing. They also ran flap actuation tests to verify the control surfaces move correctly. SpaceX officially confirmed on March 8th that Ship 39's cryo-proof campaign was complete. They called it the first full test campaign for the next generation Block 3 Starship. The same weekend, Ship 39 rolled back to the production facility while Booster 19 rolled out to Pad 2, passing each other in opposite directions on the road between the sites. Ship 39 is now back inside Mega Bay 2 getting final work done before the next phase. The biggest remaining task is installing its engines. It will receive 6 Raptor 3 engines total, 3 sea-level versions, and 3 vacuum versions built for operation in space. Once those are mounted, Ship 39 will go through its own spin primes and static fires at the ship test stand. After that, the plan is to stack Ship 39 on top of Booster 19 for the full integrated vehicle, which will fly together on Starship Flight 12. The timeline for Flight 12 currently points to early April, assuming testing goes well and regulatory approvals come through on schedule. The previous version of Starship, called Block 2, flew its last mission on Flight 11 last October. That wrapped up a year that started rough, with the upper stage being lost on 3 consecutive flights in January, March, and May. The program recovered and the final 2 launches of the year were considered full successes. But it was a hard road to get there. Here is why all of this matters beyond the test numbers and the engine counts. Starship is the first rocket ever designed to be fully reusable. Not partially reusable, fully. Every part comes back and flies again. Block 3 is the version expected to actually start proving that idea works in practice. The Super Heavy booster has already landed back at the launch site 3 times, caught midair by the Mechazilla tower's mechanical arms. But the upper stage has never been caught. That changes with Block 3. The second pad at Starbase now has its own tower and catch arms. For the first time, SpaceX has the hardware in place to attempt catching the ship as it comes back from space. If that works, both halves of the vehicle are recovered. Both halves fly again. The economics of spaceflight shift. And SpaceX cannot afford to be slow right now. NASA has a contract with SpaceX to build a version of Starship that will land astronauts on the moon. The mission is called Artemis 3. NASA recently moved that launch target up to 2027. Under the current plan, the crew flies to orbit on NASA's Orion capsule, meets the Starship lunar lander in orbit, then continues to the moon together. But here is the pressure. NASA also contracted Blue Origin to build a competing lunar lander called Blue Moon. Both companies are building toward the same mission. NASA has said clearly that whichever lander is ready first could fly on Artemis 3. If only one is ready, the other misses the first crewed moon landing since Apollo 17. That mission could then shift to Artemis 4 instead. That is what is riding on the static fire scheduled for Booster 19. Not just a test, not just data. The whole chain of events that leads to humans walking on the moon again runs through this pad, this booster, and these 10 engines about to light for the first time.